Hi guys, welcome back to my mathematics tutorial. My name is Peter S.C. Doppler Jr., your math tutor and an instructor of mathematics at the University of Liberia. In my today's video, I will be looking at differential equations, like we've been discussing differential equations in our past lessons. So we want to also deal with variable separable method of solving first order and first degree differential equations. So we say in the first type of variable separable problems, we say if you are given a differential equation and it's possible that you separate all of the x expressions on one side of the equation and all of the y expressions on the other side of the equation, if there are two variables x and y given to you in the problem, then it means that you can apply variable separable method by integrating both sides of the equation to find your general solution. And if there are values, initial values, you can find the particular solutions. But what about cases that it's not possible that you separate the variable at the first look at the problem? Sometimes it's like difficult in separating the variables. Then you test the second type or the second case that has to do with reducible to variable separable. So reducible to variable separable is a case wherein you bring in some substitution. You substitute some portion of the differential equation to a new variable or a new function, such that when you find its derivative, you take it back to the problem, and that particular differential equation now becomes a variable separable differential equation. So let's look at an additional problem. We saw a few problems in the last lessons. So let's look at question number 39 or example 39. We have x plus 2y times dx minus dy equals to dx plus dy. So the first thing we need to do here is to ensure that we have the dy by dx solved for. So to do that, we multiply this. So now we're going to multiply the individual terms, but just this factor. So this factor times the first term here is x plus 2y dx. This factor times the second one is x plus 2y dy. Then equals to dx plus dy. So all of the terms with dx or dy, we can group them. So all of the terms with dy, we group them. So we have x plus 2y dy. We send this one across minus dy equals dx. We send the one across, becomes minus x plus 2y dx. So all of the terms with dx or dx, we have grouped them, and all of the terms with dy, we've grouped them on the other side of the equation. So we can also multiply the entire expression by minus 1. Multiply by minus 1 to get rid of this negative right here. So this now becomes x plus 2y dy plus negative times negative is positive. Negative times this one is negative. And then negative times this one is going to be positive. So we're going to take the positive first. 2y minus dx. So this is dx. And then minus dx. So now what we also do is to factor out the dy. So we factor out dy here, and we also factor out dx. So if dy is factored out, what is left here is x plus 2y plus dy into dy is just like 1. Similarly, dx is factored out, so we have x plus 2y. So dx into dx is just 1. Now remember 1/8 in the form of dy by dx equals to the function, right? So what we need to do is, since we need dy by dx to be the subject of the equation, so we don't need this expression, x plus 2y plus 1. We don't need it, right? We can divide it on both sides, x plus 2y plus 1. Similarly, we don't need this dx here because we want this dx to be under this dy, so we can divide both sides. So now we can have this carrying this out and this carrying this out. We will now have dy by dx is equals to x plus 2y minus 1 all over x plus 2y plus 1. So this is the new differential equation. Now we can do the substitution. That is, we say let u equals to x plus 2y, x plus 2y, x plus 2y. Let u, we cannot say let u equal to x plus 2y minus 1 because this is 1. This is not a variable. So when this entire thing is just a single variable minus 1, this then is being expressed in terms of one variable. So we're not really concerned about the constant there. So down here we can say du now by dx, the derivative of u with respect to x is equals to 1. The derivative of x is just 1 plus the derivative of 2y now is 2. Then we attach dy by dx since y is a function. So we can further simplify that one there, thereby solving for dy by dx because dy by dx is in the equation. So if we solve for dy by dx, we're going to have du all over dx minus 1 equals to 2 dy by dx. So we want to get rid of this dy, this 2. We can multiply this whole thing by 1 over 2. So this now becomes 1 over 2 du by dx minus 1 over 2 all equals to dy by dx. So anyway I see dy by dx, I'm going to put 1 over 2 du all over dx minus 1 over 2. So this is it. Then equals, so the first two terms is just u, then I have minus 1 divided by u plus 1. So what I need to do now is to get rid of the denominators. So the LCD 2 dx and u plus 1. So it's 2 u plus 1 times dx. So this factor, 2 goes into this and this cancel. You're left with u plus 1 dx. Okay, so this is dx also. So sorry. So this is dx. So dx and dx will also go out. You'll be left with du. The next term, 2 goes into this, 2 and 2 cancel. You'll be left with minus u plus 1 times dx equals. So u plus 1 goes into this, u plus 1 and u plus 1 cancel. You'll be left with 2 times u minus 1 dx. So the next goal is to ensure that all of the terms with the du be one side of the equation and dx other side of the equation. So we have u plus 1 du is just equals to 2. So I can even multiply 2 times this is 2u minus 2. And then the dx, so this one goes across, it becomes positive u plus 1 dx. So it's u plus 1 dx or du equals. So dx and dx, so I can just keep dx here. So when dx is out now, this area is just 2u minus 2, and then this is plus u plus 1. So if I simplify further, I will have 2u plus u is 3u, and then 2 minus 2 plus 1 is minus 1 dx. But again, I do not need x here. Let's say I do not need expressions with u. I need expressions with x since this is dx. So I must divide both sides by 3u minus 1 so that I get rid of 3u minus 1 from this side. So what am I left with? I'm left with u plus 1 du all over 3u minus 1 equals dx. So we can now integrate both sides because why? Because the variables have been separated, so we can now integrate both sides. So we now have an integral problem, an indefinite integral problem. So we can apply long division because the power of the denominator is equal to the power of the numerator. So we apply long division. So we say 3u minus 1 divide u plus 1. So this 3u into this u is like saying 3u goes into u. U and u will cancel, you'll be left with 1 over 3. So it goes at 1 over 3. So 1 over 3 times 3u is just u. And then 1 over 3 times minus 1 is minus 1 over 3. So we attach a negative. This and this will go out. You'll be left with positive 1 over 3 plus 1. So 3 times 1 is 3 plus 1 is 4. So this now becomes 4 over 3. So now whenever we apply long division or we divide like this, the result now becomes the partial quotient, which is this one, 1 over 3 du, right? So this now is rewritten as 1 over 3 du plus the integral of the remainder, which is 4 over 3, divided by the divisor. And the divisor is 3u minus 1 du, all equals to the integral of dx, which is just x. So now we know that the integral of dx all over ax plus b is just equals to 1 over a, the ln of ax plus b, plus some arbitrary constant c, natural logarithm. So likewise with this one, now this is 1 over 3 u plus 4 over 3. So the integral of, now if this 4 over 3 comes outside, you just left with like saying 1 over this. So the integral of this is now 1 over a. So this is our a3. Okay, so it's 1 over a. And then times the ln of ax. So this is a and u, 3u minus 1 equals to x plus some arbitrary constant c. So what next? We need to bring in the value of u. So we know that 1 over 3 u is, so from the beginning of the problem, we said u was equal to some x plus 2y. So x plus 2y was our u. Plus, so this is now, this time this is 4 over 9 ln of 3u. U is x plus 2y minus 1, or equals to x plus c. So we can further simplify the problem by getting rid of the denominators, those fractional coefficients. So we can get rid of all of those denominators. So to get rid of these denominators, we find the LCD for the denominators. So if we look at the denominators, 3 and 9, the LCD is 9. So multiply the entire expression by 9. So 9 times this first one. So it's like saying 9 divided by 3. So 9 divided by 3 is just 3. So it's x plus 2y. Plus, now 9 times this 4 divided by 9. 9 and 9 will go out. You'll be left with 4. So we have 4, the ln of 3x plus 6y minus 1. Or equals to 9 times x is 9x. Plus 9 times c is 9c. So we can further simplify 3x plus 6y plus what? This one? 4 ln of 3x plus 6y minus 1 equals to 9x plus 9c. So this 9x and this 3, if 9 goes across, or we even bring this on this side of the problem, right? So let's send 9 across. So we will have, let's send the 3 across, in fact. We will have 6y. In fact, we want to send everything across and just solve for y, this y. Even though y is in here, but let's just make this y the subject. That's one way to, simplify the problem. So if we want to send everything across, it will be 9x minus this 3x. So this one goes across, it becomes negative 4 ln of 3x plus 6y minus 1, and then plus 9c. So what happens here, 9 and this, so it's 6y equals 9 minus this is 6. So it's 6, this and this is 6, right? So this now gives us 6x minus 4 ln of 3x plus 6y minus 1 plus 9c. So probably I want to make y the subject. I can say I divide all sides by 6. 6, 6, and 6. So this now will be 6, y equals to x minus, now this is 3, 2 into this, 3 times, 2 into 4, 2 times. So we're left with 2 over 3, the ln of 3x plus 6y minus 1 plus 9. 9c over 6. Whatever way you want to do it, whether you want to simplify it or not, but the fact that this entire expression is a constant, it means it's a constant. So we can just represent this entire 9c over 6 with some other letter and refer it to as a constant. Because if we were to verify this this solution to be a solution of this differential equation, the first thing will determine how many arbitrary constants within the solution. So if we are seeing one arbitrary constant, it means we must differentiate once and simplify to go back to the differential equation. So let's assume you had 9c over 6. The derivative of 9c over 6 is 0. Let's assume you replace this with some a. The derivative of a is 0. So it doesn't really matter what you replace it with. So we just have some a. So this is actually our general solution, or if you like, you can rewrite it as x minus. So I want to take this 2 or 3 and make it to be the power of this argument right here, 3x plus 6y minus 1, 2 over 3 plus a. So this doesn't really matter. All of these things I'm doing, I'm just trying to further, simplify it or put it in some compact form, but it doesn't really matter. As long as you have found the solution in whatever forms that your instructor may require you of, you can rewrite it and submit it. So thanks ever so much for watching. See you in our next lecture. Please don't forget to subscribe to our YouTube channel, like our videos. See you next class. Thank you. Math is fun. Let's always have fun. Thank you.